Okey, mari kita mula semula. Right. Okay, as I mentioned earlier, we have two major processes that we discuss in SBK 3013. Sebenarnya ada banyak lagi kan, but for this one we're going to look into fatty acid degradation and fatty acid synthesis. For fatty acid degradation, we've discussed that during the guest lecture UNY, and it comprises of four stages or four processes: oxidation, hydration, and then oxidation again, followed by cleavage. So this is to produce acetyl-CoA. We have fatty acid, and finally it will produce acetyl-CoA. On the other hand, we have another one, which is fatty acid synthesis, where it also involves four processes: condensation, reduction, dehydration, and reduction. But the product or the end product of this process, of course, is going to produce fatty acid. If you compare between two, the major thing that we can observe right here is the location of the process. For fatty acid degradation, here in the mitochondrial matrix, whereas for fatty acid synthesis, it occur in the cytosol. Lokasi pun berbeza. Okay, apa lagi yang berbeza? If you look at the process of fatty acid degradation, it is coenzyme A dependent. So it depends on the existence or the presence of coenzyme A. However, for fatty acid synthesis, it is ACP dependent. It depends on ACP. ACP is acyl carrier protein. Acid carrier protein. What else? For fatty acid degradation, we have FAD, NAD plus dependent, fatty acid synthesis, and ADPH dependent. For fatty acids beta oxidation, it requires multiple enzymes, and for this one, two enzymes. And here, the carnitine transport is the rate limiting, meaning that carnitine transportation is the one that control the production of acetyl-CoA or the process of beta oxidation. So that is what it means by rate limiting. Dia kawal lah. And as well for fatty acid synthesis, it also has rate limiting component. In this case, the malonyl-CoA synthesis is the rate limiting. When we have malonyl-CoA, if that is synthesized, that will be a trigger for the production of fatty acid. Kalau dia tidak dihasilkan, dia akan menghentikan ataupun inhibit the production of fatty acid. Kalau you jumpa mana-mana perkataan rate limiting tu, berarti dia itulah yang jadi punca ataupun the point that control the whole processes. It's the regulation lah. It's the regulation of that process. Okay. Let's move on to the next slide. Ini adalah the terminology or the concept or the points or the information yang kita kena ingat lah. Untuk menghasilkan fatty acid synthesis. So, dia memerlukan substrate. Substrate dia, the carbon substrates is actually come from makanan yang kita makan. From the dietary carbohydrate in form of glucose. So, nak menghasilkan fatty acid synthesis tu, nak menghasilkan fatty acid tu, it comes from ataupun sumbernya datang daripada makanan. It can come from carbohydrate. Bila kita makan, ada digestion and then dia form lah glucose kan. So glucose tu lah yang akan menjadi sumber ataupun sumber kepada karbon bagi menghasilkan fatty acid. Gitu. Apa benda lagi apa? It will be used, glucose ni tadi ataupun carbon substrate tu tadi, will be used to generate apa? It will be used to generate acetyl-CoA and glycerol for the production of tax. So kadang-kadang saya sebut lipid, kadang-kadang saya sebut triacylglycerol, kadang-kadang saya sebut TAG. So I'm referring to the same thing. Ataupun acylglycerol triacylglycerol. So that glucose will be used to generate acetyl CoA and glycerol for the production of TAG or triacylglycerol. Tu idea dia. So dalam kepala kita kena ada lah that idea of apa benda sumber karbon tu datang daripada mana. Maksudnya makan nasi tu lebihan gula tu it can help to produce asid lemak, fatty acid. Okay. Let's move to the next slide. Kejap. Alright. Ini saya akan tunjukkan the idea of kita punya biochemistry of Ramadan fasting tu. So basically, kalau kita tengok dia punya cycle ni, we can start with the food consumption right here. Food consumption, kita makan. And then lepas kita makan tu, there'll be situation where kita dalam keadaan state, in the state of dah makan dah makan. So absorptive state ataupun fat state ni. Waktu fat state, if you look closely, increase of glucose, insulin secretion and so on and so forth. So ada juga nanti bila kita dah makan tu, the fat will be stored in adipose tissues. So kalau kita quickly recall balik, I'm going to click to that star kat situ. It's supposed to bring me here. Ini yang last section kan, kita bincang sedikit dalam ni. Bagaimana from the diet, it move into the intestine, ada emulsification from the bile salts, and then masuk through the intestinal mucosa, and then it will be carried by chylomicron. So and then it will move into the blood capillary, and there'll be activity of lipoprotein lipase and activate the ApoC2 and then release fatty acids and glycerol. Ini semua kita dah bincang. And then finally the fatty acids will enter the cell and reform into TAGs or triacylglycerol, and then it will stored as TAGs dalam myocyte ataupun adipocyte. That is how kita simpan lah. But it depends lah. Sometimes there will be incident where we need to use that fatty acid, kita akan pecahkan. Pecahkan tu yang the one that kita lihat pemecahan through beta oxidation tu. Let's say lepas kita dah makan tu, after 4 hours, kita pun puasa lah. After that 12 hours, we still berpuasa. Ini kalau recall balik yang kita puasa dulu tu kan. After that, about 8 hours lepas tu dalam jam ke-12 macam tu here, hour 12, we entering the pause, we enter the post absorptive state. Kita pun masuk kepada post absorptive state, early fasting. This is where we can see the initiation of lipolysis. The word lysis tu, if you encounter any perkataan lysis, pecah, maksudnya pecah lah. Bila perkataan lysis tu, it means pecah. So that is where the free fatty acids will be produced. Initiation of pemecahan lemak tu. So macam mana berlaku? I'm klik here dekat bintang-bintang ni. Tak pergi pula. Okay, macam tu lah. Fatty acid, kita ada triacylglycerol, ni semua tahu. Dalam chapter buku form 4, you akan tengoklah nanti dalam chapter buku form 4, chapter berapa saya pun lupa pula. Chapter 4 kot. So adalah cerita pasal teks tu nanti. It will be broken down into glycerol and fatty acids. Lipolysis kan, pecah kan. So the glycerol will be used in glycolysis to form pyruvate. The glycerol can also be used in formation of glucose balik. Gitu. Banyak function fatty acid ni. Macam mana dia nak form balik into glucose? Through gluconeogenesis. This one kita pun dah tahu dah. Banyak kali tengok tentang gluconeogenesis ni. And then apart from that, because we know that triacylglycerol tu consists of 1 glycerol and 3 fatty acid. What happened to the fatty acid? Kalau you buat macam ni kan, macam ni macam pengakap lah kot This is glycerol and then we have 3 fatty acid. Yang 3 ni jadi apa? Glycerol, we know the fate. It will go to the liver cell and then it can form back into pyruvate. It can form into glucose by different processes. Fatty acid ni jadi apa? Fatty acid ni will be further breakdown through the process of fatty acid oxidation. Pecah melalui fatty acid oxidation. Maybe you have watched the video. That video mainly concentrate on fatty acid oxidation. Kalau you recall balik gambar rajah ni, some of you have already submitted worksheet tu. Ada yang tak hantar lagi pun ada. So this is the process. Kalau kita tengok sebelah kanan tu, sebelah kiri tu, itu ialah laluan dia. And then bila tengok yang sebelah kanan tu, that one is referring to the process of the how that fatty acid is transport into the matrix mitochondria for the process of beta oxidation. Ini baru transport lah. Lepas dah masuk dalam matrix mitochondria tu, it occur, beta oxidation will take place. Beta oxidation will take place where dia ada 4 stage yang as I mentioned earlier tu, ada process, all the processes will produce the energy molecule. FADH tu will produce into apa lagi? NADH. These are all energy molecules that will be further converted ataupun the energy will be carry in the molecule. Energy tu nanti will be will be used to form ATP dalam electron transport system tu nanti. Dalam sistem tu nantilah. But what happened to acetyl-CoA? Acetyl-CoA, as we know, it can go into Krebs cycle or TCA cycle to produce more of energy molecules. Itulah cerita dia. So, adalah kegunaannya di situ. Recall balik the processes, or you can baca buku pun, it will be a quick one pun kan. Okay, going back to the page tadi. Sampai dekat hour 12 tu, that is for the lipolysis. Tetapi, there'll be incidents kalau kita tak puasa lah. Ni cerita kalau kita tak puasa. Kalau kita puasa, dia akan move from jam ke-12 and further to maybe ke jam ke-24 ke jam ke-16 kan. But what if kita ada excess of glucose? Kita makan lebih pula hari ni. Contoh macam hari raya. Hari raya ke hari yang tak raya pun, kita ada excess of carbohydrate. What would happen to the body? So I'm going to click to this pink pula, warna apa ni, biru. That is where we are going to form lipid ataupun form the fatty acid tu. Lipid pula, fatty acid. That is where we call it lipogenesis. Pembentukan fatty acid tu dulu, kemudian barulah ada gabungan dengan glycerol to form into fatty lipid. Dia bentuk fatty acid dulu. Bentuk fatty acid, combine with glycerol, barulah jadi lipid ataupun tax tadi tu. Ini yang kita tengok, the one that we are looking at now is monoglyceride. Satu je fatty acid. But the rest of it, when they combine dengan other fatty acid, dia akan jadi triglyceride lah ataupun triacylglycerol. Ada tiga. So that is for lipogenesis. But for SBK303, kita tak tengok lah yang dalam peroxisome lah, dalam macam-macam lah semua benda-benda tu kan kita tak tengok lah. Kita just tengok, terus kita tengok pada macam mana fatty acid tu dibina. How fatty acid is synthesized. Okay, saya klik sekejap to the next page. Dalam ni pun, ini lama saya guna gambar rajah ni because dia memudahkan lah. Okay, let's look at the fatty acid synthesis ni. Dia ada, it's not confusing, but dia ada stages lah to produce product. Dia nak bina ni quite, it requires energy. It requires energy and it requires number of substrate. Let's look at the first one. I'm going to walk you through of how fatty acid synthesis happens. Dia punya tujuan ialah untuk menghasilkan palmitate ni. Tujuan dia lah untuk menghasilkan palmitate ni. Dia ada 16 carbon. If you look at the carbon here, ada 14 right here, and then kita ada one more right here, 15, and then kita ada one more right here, so 16. Ada 16 carbon. That is how the body produce. Palmitate ni macam pokok palma je, minyak kelapa sawit ke? Tak. Kita manusia boleh menghasilkan palmitate. because it's 16 carbon, kita panggil dia palmitate lah. That's the purpose. Later on, after tu yang nak menghasilkan lain-lain punya fatty acids tu, it gonna involve other types extension of processes, the process of elongation, nanti ada yang menambahkan double bond, yang keluarkan hydrogen. There's a lot of thing of modification will happens after the production of palmitate. Maksudnya mula-mula dia akan hasilkan palmitate. First thing first, it will produce palmitate. After that, then only you will produce other type of fatty acids. It can be saturated, it can be elongation, it can be unsaturated, it can be ada double bond ke, it can be ada single double bond ke, so many things. So there will be some modification after the palmitate is produced. Itu cerita dia. Now, let's look at step by step the production of palmitate ni, macam mana dia berlaku. First of all, substrate yang diperlukan, the main substrate which is required adalah acetyl-CoA. We call it the process of priming. Nama dia priming. So priming is is the one that we require to start off the process of synthesis. Itu satu. Acetyl-CoA. Tengok kat sini. Ni acetyl-CoA. Acetyl-CoA. We have one acetyl-CoA. If you look here, kita ada ACP. Apa ke nama ACP tu tadi? Acyl carrier protein. Recall balik page pertama tadi saya tunjuk apa tu dia, proses ni adalah ACP dependent, dia bergantung pada ACP tu. Now dia dah ada ACP dengan CoAsh tadi tu dia ada ACP, so it require transacylase enzyme where the combination antara kesemua ni akan menghasilkan acetyl ACP. Akan menghasilkan acetyl ACP. So this is the structure. Kat sebelah ni kalau kita tengok, 2 carbon of acetyl and then kita ada ACP. ACP, acyl carrier protein. So apa berlaku kemudian? Tersedap lah. Kemudian we will require the attachment of an enzyme. Tambah enzyme. Yeah. The enzyme name here is synthase. So this is where this carrier protein akan keluar. Dia akan detach from the acetyl ACP. They will detach from the acetyl ACP. Instead, dia macam tukar lah. Dia tukar. Carrier ACP, SH ni keluar ataupun carrier protein ni akan keluar. And then synthase will comes in. Synthase ni lah enzyme. Therefore, kita tengok apa yang terhasil? Acetyl synthase. In biochemistry, we also have a substrate which is attached with enzyme. A complex to attach with enzyme. You can go to the book that I mentioned just now. Dia tunjuk structure tu. I think at this point, if you are interested, you can look at the structure. Otherwise, kita boleh tahulah setakat ni okay saja. But if you want to go beyond, I encourage you to do that. Okay, sekarang dah hasil dah acetyl synthase. Berapa karbon acetyl synthase ni kita tengok? 2 karbon. 2 karbon ada 2 karbon. Mari kita tengok yang sebelah satu lagi. Sebelah satu lagi ialah pembentukan malonyl. Nak menghasilkan malonyl ACP. Inilah malonyl ACP. Nak menghasilkan malonyl ACP. Bagaimana nak buat? Sama juga. Kita perlukan acetyl-CoA. Sama juga. Kita perlukan acetyl-CoA. Meaning, to start off, total of acetyl-CoA required adalah 2 lah. Satu semasa priming, untuk priming. Satu lagi untuk membentuk malonyl ACP. Right? Satu kat sini. Satu lagi kat sini. 2 acetyl-CoA to start off. Okay, so what happened to acetyl-CoA? It will undergoes a carboxylation. Tengok kata ni, carboxylase enzyme ni meaning that we are going to add carbon. Berarti ada penambahan carbon. Mana nak datang carbon tu? It comes from carbon dioxide right here. Dia datang daripada carbon dioxide. Remember that for synthesis activity or process, kita akan perlukan tenaga. We need energy to form new things. That is anabolic reaction kan? Anabolic reaction. So here kita perlukan ATP. So we're going to get this ATP and to help in the carboxylation. Kita pun dapatlah satu ni, melanin-CoA. Menghasilkan melanin-CoA. Tadi acetyl-CoA 2 karbon. Sekarang kita ada 3 karbon. 1, 2, 3 karbon. We have melanin-CoA. However, kena ada dalam mindset kita nak hasilkan melanin ACP. So how we going to do that? Kita perlukan another carrier protein, SCP is acyl carrier protein to come into the situation, to come into the process. Therefore kita dapatlah melanin ACP. CoH keluar. So gantilah tadi ni kita dapatlah acyl carrier protein attached to melanin CoA. So sama juga ni ada 3 karbon. What's next? So this is the next process ni. Kita dah ada product, kita dah ada substrate, acetyl synthase, product acetyl synthase and melanin ACP. The third process is known as condensation. Perkataan condensation tu kita tahu bahawa it will involve in the process of formation of acetyl ACP ni, where the process will reduce the carbon number. Reduce the carbon number. Mari kita tengok sini. Ini tadi 2 carbon plus 3 carbon. Supposedly dia akan jadi 5 carbon. But since the condensation comes in, process condensation comes in, where the carbon will be released or the carboxylation, carbon will be released right here, carbon akan keluar. Instead of the product is 5 carbon, now it becomes only 4 carbon. Kalau tengok kat sini, 1, 2, 3, 4. 4 carbon kat sini. 4 carbon, nama pun dah lain, acetyl ACP. Dia jadi acetyl ACP. Okay, what's next? This is where the first reduction first reduction where we use NADPH as the energy will comes in. Di mana NADPH ni lah yang akan contribute or supply hydrogen kepada acetyl ACP. You guys good? Boleh follow tak so far? Dah masuk first reduction ni? Okay ke you all?
Okay.
Takut saya cakap seorang-seorang. ada reaction apa tu kan, you just baca je lah thumbs up ke apa benda kan. So, saya pun pernah juga cakap seorang-seorang, tiba-tiba rupanya memang saya line saya dah keluar daripada Google Meet tu, because when I do my explanation, I'm not looking at Google Meet tu, saya look at different screen. Tu cerita dia. Okay, mari sambung. Okay, after the first reduction tu, so the first reduction is where we use NADPH to supply hydrogen ion. Meaning that NADPH will lose dia punya hydrogen ion tu. When it loses dia punya hydrogen ion, something yang akan terima. Yang akan terima the hydrogen ialah acetyl ACP. Now, if you look closely pada this part yang merah ni, not so sure whether that one appears red at your end, yang kawasan ni. This is where kita akan ada pertambahan hydrogen. Pertambahan hydrogen which comes from NADPH ni. Dia ada pertambahan hydrogen kat situ. Now, dia pun akan menjadi satu substrate, satu intermediate yang baharu, iaitu 3-hydroxybutyryl ACP. So dia ada berapa carbon? Still sama juga 4 carbon. Still 4 carbon, except for dia ada additional of hydrogen in hydrogen in the substrate ataupun in the intermediate. Okay, tu cerita dia. So kita dah tambah hydrogen kat situ. Apa tujuan kita tambah hydrogen ni? Sebenarnya kita nak hasilkan dia CH2, 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 CH2 tu. Kan kita nak hasilkan ni, palmitate ni. Ujung-ujung ni kita tambah hydrogen. Kalau kita tengokkan kat sini ada oksigen kan. Ni ada oksigen, kat sini pun masih ada oksigen. We need to remove it. Kita kena keluarkan dia. Supaya at the end ni, kat belakang sini, tak ada oksigen. That is lipid, that is fatty acids. Kita ada CH2, 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 CH2. Depends lah kalau for palmitate, CH2, 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 CH2. Tak ada oksigen pun. And then CH3 kan. So that's the thing. We need to remove oksigen ni juga. Lepas ni kita nak remove oksigen ni. First kita add je hydrogen, so akan jadi structure ni. Kemudian kita nak remove this oxygen. Macam mana nak buat? That is where the process of dehydration comes in. Water is removed. Ni kat sini. We're going to remove water molecules. Bila kita remove water molecules, meaning kita akan keluarkan 2 hydrogen dan 1 oksigen. Tadi kita tambah hydrogen. Sekarang kita nak remove pula. Kenapa berlaku macam tu? Because of the process, when you cannot simply remove water molecule directly from acetyl ACP. You cannot do that. Cannot remove terus nak buat dehydration for that molecule. It will not act as what we want. The body will not do that. That is the process because of the nature of the structure of acetyl ACP. You cannot remove oxygen ataupun skip satu step. We cannot do that. That's the beauty of how Allah creates the processes. Kita perlu lalui hydroxybutyryl ACP, and then from there kita go for dehydration. Bila berlaku dehydration, if you look closely, let me get pemadam tu kejap ya, supaya tidak mencomakkan dia. Mana pemadam ni? Tak padam pula. Tak apalah. Okay, never mind. Tak responsif pula pemadam tu. So jangan tulis teruk-teruk. So tak apa. Jadi ini kita akan remove water molecules. Look at the structure ni tadi. Bahagian sini tadi. What happens? Kita akan dapat a double bond. Sebab apa? Dah remove hydrogen, dah remove oxygen. Carbon always kena ada 4 ikatan kan? Always kena ada 4 ikatan. So because of we have removed water molecules kat sini, dia akan jadi double bond pada carbon ini. So now that we have CH3, CH. To make this double bond jadi single. Jadi single bond. Nak jadikan dia single bond, of course the best solution is to add in hydrogen. Kita tambahlah hydrogen baru dia tak ada double bond kat sini kan. So that is where another reduction comes in. That is the second reduction. The second reduction also require an ADPase as the reducing agent, di mana finally kita akan dapat a saturated fatty acid kat situ. Kita ada CH2, CH2, CH3. Nama pun dah berubah. Nama dia butyryl ACP. So sekarang butyryl ACP ni ada berapa carbon? 1, 2, 3, 4. Ada 4 carbon. Itulah cerita dia. Kita dah dapat dah 4 carbon yang saturated with hydrogen. Tak ada oksigen kat situ. Tiada double bond. There's no double bond. There's no oxygen. It's gonna be a straight one. CH2, CH2, CH3. Right. Remember that our intention or the purpose is to produce 16 carbon. We want to produce 16 carbon. Meaning kita kena tambah lagi ni. Kita kena tambah carbon ni. We require another 12 carbon. Kita perlukan 12 carbon. Okay, bila kita perlu 12 carbon, we need another 12 more carbon. Every cycle ni yang kita tengok tadi tadi kita start daripada 3 sini, 3 carbon, kita tambah 2 carbon. 3 tambah 2 because ada decarboxylation, dia jadi 4. So kita nak tambah lagi 2. If you recall for fatty acid oxidation ataupun beta oxidation, it removes 2 carbon, 2 carbon, 2 carbon. It removes 2 carbon at one cycle. Every cycle it will remove 2 carbon. As for fatty acid synthesis, every cycle dia tambah 2 carbon. Every cycle it will add 2 carbon. 2 carbon tu datang daripada sini lah. Dari sini datang daripada acetyl synthase. Tak ada dah malonyl ACP ni. Tak ada dah, wait, where is it? 6 cycle. Tak ada dah acetyl synthase, tak ada dah acetyl synthase ni. Dia ada malonyl ACP ni because this is ialah substrate dia. So sekarang apa yang berlaku, this butyryl ACP ni, dia akan melalui apa yang telah dilalui oleh acetyl synthase. Dia akan melalui apa yang telah dilalui oleh acetyl synthase. Dia akan jadi 4 carbon. 4 carbon and then ada malonyl ACP, 3 carbon, sepatutnya jadi 7 carbon. And then kita akan remove 1 carbon. Dia jadilah 6 carbon. Nama dia dah bukan acetyl ACP dah. Dia akan jadi nama lain. Yang 6 carbon. 6 carbon and then jadi dia pun akan melalui reduction. First reduction still 6 carbon. Dia will undergo dehydration still 6 carbon. And then dia akan lalu the second reduction still 6 carbon. And finally kat sini dia akan jadi 6 carbon lah. Dia nak tambah CH2, 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 CH3. So this 6 carbon akan lalui lagi the process of combining with malonyl ACP. Tadi dia dah ada 4 carbon, now dia jadi 6 carbon. So that 6 carbon plus 3 carbon jadi 7. Jadi 9 carbon. 9 carbon minus 1 carbon from the removal of carbon dioxide. So dia akan jadi berapa? 8 carbon. 8 carbon, nama dia dah bukan yang ni 8 carbon. Once dah 8 carbon, dia akan go for the first reduction, still 8 carbon. They go for the dehydration, still 8 carbon. Dia akan lalu the second reduction, still akan 8 carbon. So jadilah 8 carbon di sini. Nama pun dah lain. You may want to find out what is the name for that 8 carbon, 6 carbon. For 4 carbon is butyryl ACP. For 6 carbon, apa nama dia? For 8 carbon, apa nama dia? But now we only have 8 carbon. So this 8 carbon yang 8 carbon ni pun sama. It will repeat the whole processes again. Tambah lagi 8 carbon, tambah lagi 3 carbon. Betul tak? 8 dan 3 carbon jadi 11 carbon. Okay. 11 carbon, kita ada process of condensation, dia akan jadi 10 carbon. Go through first reduction, 10 carbon. And then dehydration masih ada 10 carbon. And finally dia akan ada 10 carbon. You will go through all the processes, reduction, dehydration, second reduction. Apa berlaku pada 10 carbon ni? Dia sekali lagi pusing lagi. To replace acetyl synthase tu, dia ada 10 carbon. And then again, tambah 3 carbon. Once dia tambah 3 carbon, dia jadi 13 carbon. Sama juga, remove the carbon dioxide, go through condensation, dia jadi 12 carbon. Go through first reduction, still 12 carbon, ditambah hydrogen saja. Go to dehydration, just remove water molecules, still dia ada 12 carbon. Go through the second reduction, now dia dah jadi 12 carbon. Betul? 12 carbon. Sudah jadi 12 carbon and then pusing lagi. 6 kali pusing. So 6 round of it, sampailah it become 16 carbon. Then this is the part where it will go into a modification, nak modify the fatty acid, it will go through the process of elongation. Ada lagi lah processes lain but whatever the processes will be, it depends on the body requirement. The main thing that we need to know ialah the first thing, dia akan produce 16 carbon ataupun palmitoyl ACP. Lepas 6 cycle tu, every cycle it will add 2 carbon. Every cycle it will add 2 carbon. 1, 2, 3, 4. Dia add lagi lah. Dia pusing sampailah jadi, ni jadi 14 carbon, add lagi jadi 16 carbon. Sampailah jadi palmitoyl ACP. And then when we remove that ACP from the palmitoyl, kita akan dapat palmitate. Itulah cerita dia. That is how the fatty acid synthesis happens in the body. Kita pun adalah fatty acid dalam badan. Itulah cerita dia. Or you can go to this book. Ini buku ni Essential Biochemistry. Essential Biochemistry. Buku ni, dalam buku tu, this one also I crop it from the book. You can find, this is the ebook that I already sent you. Fatty acid synthesis. Dia akan tunjuk step by step and some simple explanation there. Apa yang berlaku sehinggalah dia menghasilkan palmitoyl ataupun palmitate at the end. Itu cerita dia. That's the quick explanation je lah. A quick explanation. You can read that one more from the book. Let's go to the main page. Itu ialah apabila kita ada excess of glucose. So that is where the synthesis of fatty acids comes in. We can produce more fatty acid. Do we need fatty acids in the body? Mestilah perlu fatty acids in the body. Okay, now let's look at our diagram. The next thing after 12 hours, kita taklah puasa sampai 36-48 jam kan. Sampai 16 jam kita akan break our fast and we will not go into this state of sampai 36-48 jam tu tak. Tapi just a quick sharing, during the fasting state tu kita sampai 18 jam, 12 jam, 18 jam, kita puasa berapa 16 jam macam tu. So this thing will still happen. Kita akan start ada berlaku gluconeogenesis, we'll start to use fatty acids and ketone as fuel, it's still going to happen. But it depends on type of individual punya body storage lah kan. Kalau memang dia dah ada banyak storage of carbohydrate storage ke glycogen pun still ada, so dia still akan guna juga. Now let's look at how are we going to use fatty acid. Tadi kita guna fatty acid, kita akan break down through fatty acids oxidation. Kalau ketone, ada satu lagi ketone ketone ni another way of how the body will use. Bila kita dalam keadaan prolonged fasting, dalam prolonged fasting tu we can use the ketone body. Sewaktu berpuasa pun ada stage yang kita akan go for this ketone body utilization. Ketone body ni kalau tak guna dalam badan, it can become toxic to the body. Itu cerita dia. Now let's look at bagaimana ketone body terhasil. Okay. Before we look into how ketone body terhasil ni, I'm going to give you a quick break dulu. Kita break dulu sekejap. Can we continue at 4?
Boleh doktor.
Boleh doktor.
Okay, you can leave the Google Meet and come back again, ataupun you can stay online. Kita mula balik ke 4. Take a break and go and walk somewhere ke, minum air ke apa benda ke. Okay, see you at 4.